Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. I would like to apologize as I am starting this problem solving a bit late due to Republic Day being today. Okay, so let's continue with the problem, fractional knapsack. So let's see what the problem is saying. So the problem is saying that we will be given certain items, right? Certain items with weight and value, Okay, and we'll be given a knapsack, right? With its own capacity, right? With its own capacity. This is weight basically. Okay, so what we want to do is we want to push the items right into this. We want to push the items into this knapsack in such a way that we produce the maximum value. Okay, maximum value. We need to have the maximum value when we put the items. So how the value is determined? Basically, if you see, each item has weight and value, weight and value. Okay, weight and value. So we want to push the items in such a way that we produce maximum value. Okay, now how we will calculate the maximum value, right? So for each item, now if you see, we have val, right? So we just cannot say that okay, the one item with the maximum value is the most expensive, right? Is the most valuable item. We cannot say, because the weight also comes in picture. If you see, this value is 120, but weight is 30 over here. Here the value is 60, but the weight is 10 over here, which is less, right? So what we'll do, we'll calculate the profit ratio. Okay, profit ratio. Now how we'll calculate the profit ratio? It will be value of each item, right? 60 divided by 10. Okay, for this item, value divided by weight. Okay, which will give us 6, right? Now this is profit ratio per weight unit, per 1 unit. Okay, 1 unit of profit ratio, it is 6 for this item. Okay, for this item it is 100 divided by 20, right? Which is 5, for this. Okay, and for this item it is 120 divided by 30, which is 4. Okay, so here the profit ratio for this item is 4. Now if you see, the item with maximum profit ratio is this item. Okay, so this becomes the most valuable item. Okay, now why the name is fractional knapsack? For example, fractional knapsack. So why it is fractional knapsack? For example, right, now the capacity of this knapsack is 50. Now if you put this item, right, if you put this item into this knapsack, right, so what will be the remaining weight now? 50 minus 10, right? The weight of this item is 10, right? So the capacity remaining for this knapsack, right, of weight is 40 weight. Now we can put the items with maximum 40 weight. Okay, now we'll check whether this item can be pushed. Yes, this item can be pushed completely because its weight is less than the current capacity. Okay, so now we'll push this item right into this knapsack. Now the remaining capacity will be 40 minus 20, right? 20. Now if you see here, can we push this item into this knapsack? No, because the weight of this item is 30 and the capacity is 20, right? The capacity is 20. So what we can do is we can break the item. And put into the knapsack. So now 20 is the capacity. So we can break the item in such a way that we can put only 20 units of weight, right? 20 units of weight into this knapsack, and hence the name fractional knapsack. Okay. Now how we will calculate when we how we'll calculate the value, right? The maximum value. So it will be, see, now for example, now you're putting this, how much weight you're putting in the knapsack, right? So 20, right? We were putting 20, right? So 20 into the profit ratio of 1 unit. So what is the profit ratio of this unit, right? Of this item, it was 4. Profit ratio, this 4 is of profit ratio of 1 unit of weight, and we have 20. We are pushing 20 units of weight, right? So it will be 80. It will be 80. Similarly, right? Similarly, now how much weight we are pushing here? 20, right? 20. We were able to push complete item, and the weight of the item is 20, right? And what is profit ratio of 1 unit of weight? It is 5, right? So it will be it will be 100, right? 20 into 500. And here for this 10, right? 10 into as we were able to push complete weight, right? 10 into 6, right? 1 unit of weight. So 10 into 6 will give us how much value? Will give us 60. So the answer turns out to be how much? 240, if you see, right? 240. So here is the output, 240. Okay, so now the solution, right? So what we'll do is we will sort these items according to their maximum profit ratio. So we have calculated the maximum profit ratio, the profit ratio of each unit of weight. So we are going to sort the items according to the maximum profit ratio, and then we'll keep on adding into the knapsack. If the full weight we can add, then we're going to add the complete item. Else we'll break the item, right, with whatever is the remaining capacity. Okay, so let's dive into the code. So here is a code. If you see, so first we are sorting. First we'll see the Java code and then C++ code, right? So here we are sorting the array, right? And how we are sorting the array? See, here we have item 1 and item 2, right? So what we are doing, we are see value divided by weight, right? Value divided by weight. Here what we did, it was 60, right? 60 divided by 60, profit ratio 60 divided by 10 it was, right? So value divided by weight. So here we are doing value divided by weight, right? And then we are sorting according to the, so that the array contains the items with maximum profit ratio. Okay, and then what we are doing here is, see, we are having current weight, right, which has gone into the knapsack. Okay, this is a counter for that, and we have final value, which is answer. So we'll iterate through the items, right? Now we'll check Now the array contains the items with maximum profit ratio. So we'll check. Current weight is currently 0, right? Current weight is currently 0. We'll check whether 0 plus the weight item, the weight of the item. If it is less than the capacity, the knapsack capacity. Yes, if it is, then we are simply what we are going to do. We are going to add the value. We are going to add the value. So it's nothing but so we are adding in the answer, right, the complete value, because we are able to put the complete item. So what it will be, so the weight is 10, right, for this item, right, and the profit ratio is 60, is 6, sorry, profit ratio was 6, right? So we are doing 60 here, right? We are passing 60, so which is nothing but the value itself. So if we are able to put the complete item, right, and so the will add 60 only, the complete value, and which will turn out to be what, profit ratio into the complete weight, right, which is 60 only, if you see, right? So we have put here. Also, we are incrementing the current weight, which is now the knapsack has 10 as a unit, right? And for example, right? For example, now if current weight plus, right? Current weight plus the item of the weight, right? Right? Current weight in the knapsack plus the item of the weight, if it exceeds the remaining capacity, right? If it exceeds the remaining capacity, right? The capacity, then what we are doing is, see here we are calculating the remaining weight. So earlier what it was, so here, right? What it was, so remaining weight was when we added these two items, right? When we added these two items, so what it was, 20 plus 30, right? 20 plus 30, 20 plus 10, okay, which was 30, right? In the knapsack, it was 30. And what was the capacity? What was the capacity of knapsack? Which is 50, right? So now 50 minus 30 we are doing. So this is the remaining capacity, right? W minus current weight. This is the remaining capacity. And then what we are doing is remaining. That is, for example, 20, right? Remaining into the profit ratio. Okay, value into weight, right? Value divided by weight, right? Profit ratio. So 20 into what is the value? 120. That is the profit ratio, is nothing but what? It is 4, right? It is 4, we saw. 4, right? 4. So 20 remaining weight into 4, which is 80, right? So we are adding in the final value. Okay. So yes, so this is the solution, right? Remaining, once we are done, we'll break because there's no capacity now in the knapsack. Okay, so this is the remaining, and let's submit the code. Okay. Yes, it is accepted. Let's quickly see the C++ code as well. Okay, so here if you see, we are sorting the array. It's almost, the code is almost same. We're sorting the array, right, according to the profit ratios, right? We're sorting maximum profit ratio, and then what we're doing the same thing here, almost same, right? The code is almost same, whatever we explained, right? If complete item can be put into the knapsack, then we'll put the complete item and we'll increment the current weight, which indicates the current weight in the knapsack, and final value, which is the answer, right? Maximum value, right? If it is complete item does not fit, then we'll put the remaining, right? The remaining item, and we'll multiply the remaining item into profit ratio of single unit, right? Into the final value. Okay, so this is the solution. This also will be accepted. Okay, so this is a solution. I hope you've got the solution. Please subscribe to my channel and like the video. Okay, have a happy, healthy, and a great day. Thank you so much.